Chapter 6 Application of Derivatives, Exercise 6.2, Question number 3. Show that the function given by f of x is equal to sin x is increasing in 0 pi by 2, decreasing in pi by 2 pi. C. Neither increasing nor decreasing in 0 pi. So we have given f of x is equal to sin x. So f of x is a trigonometric function. So we can write f of x is continuous and differentiable on R. So we have f dash of x, that is d by dx of sin x, that is f dash of x is equal to cos x. So first question, that is increasing in 0 pi by 2. When x belongs to 0 pi by 2, so we have the axis, the four axis, that is 0, pi by 2, pi and 3 pi by 2. So from 0 to pi by 2, we can say all the trigonometric functions are positive here. From pi by 2 to pi, we have sin theta and cosec theta positive. And from pi to 3 pi by 2, tan theta and cot theta are positive. Similarly, from 3 pi by 2 to 0, it is cos theta and sec theta positive. So from when x belongs to 0 to pi by 2, that means cos x. So in the 0 to pi by 2, all are positive. So we can say that f dash of x is greater than 0. So in the first quadrant, all are positives, right? So f of x, we can conclude from that is f of x is strictly increasing in 0 to pi by 2. On the second, that is decreasing in pi by 2 pi. So we are taking the quadrant pi by 2 pi, that means the second quadrant, that is here only sin theta, cosec theta are positive, all others are negative. So we have f dash of x, that is cos x, which is less than 0, that is cos x is negative here. So we can say in the second quadrant cos x is negative. So from this we will conclude f of x is strictly decreasing in the intervals pi by 2 to pi. Now C part of the question, that is neither increasing nor decreasing in 0 to pi. So when x belongs to 0 to pi, that means from the quadrant it is clear that at the first quadrant, that is from 0 to pi by 2 it is positive, and from pi by 2 to pi it is negative. So cos x is negative. So here we will conclude that here cos x is neither positive nor negative. So from this f of x is neither strictly increasing nor decreasing when x belongs to the interval 0 to pi. Fourth question. Find the intervals in which the functions f given by f of x is equal to 2x square minus 3x is a increasing, b decreasing. So we have f of x is equal to 2x square minus 3x. So what is f dash of x? That is d by dx of 2x square minus 3x. Or d by dx of 2x square, that is 2 into 2x, and minus d by dx of 3x, that is minus 3. Or we can write f dash of x is equal to 4x minus 3. Let it be the equation number 1. If f dash of x is equal to 0, we want to find the intervals, right? So if f dash of x is equal to 0, we have 4x minus 3 is equal to 0, or x is equal to 3 by 4. Now split R in the domain of f into the disjoint of intervals. For that, we will be drawing a line segment. So we have x is equal to 3 by 4, right? So we are drawing a line segment, marking a point 3 by 4 on the line segment. So from plus 3 by 4 to plus infinity, and minus infinity to 3 by 4. It is divided into two parts now. Now we have f dash of x. The equation for f dash of x is 4x minus 3. When x belongs to the interval minus infinity to 3 by 4. At that time, when you are applying any value in between minus infinity to 3 by 4 instead of x in the equation f dash of x is equal to 4x minus 3, we will get a negative quantity. So we can write from this, we can conclude f of x is strictly decreasing in between the intervals minus infinity to 3 by 4. Now what happens when x belongs to the interval 3 by 4 to infinitive. That is, when we are applying any quantity for x in the equation f dash of x is equal to 4x minus 3, we will get a positive quantity. So we can write f of x is strictly increasing. So we will getting a positive quantity. That means it is strictly increasing in the intervals 3/4 to infinity.